Next up in energy is kinetic energy, the store of energy found in moving objects. By the end of this video, you should be able to define kinetic energy and recall an equation to calculate it. You should be able to calculate the kinetic energy stored in a moving object and then use the rearranged formula to calculate either the mass or the velocity of a moving object. There are 8 different ways in which energy can be stored in objects, and one of these is kinetic energy, which is the energy store found in moving objects. An object will contain more kinetic energy if it has a greater mass or a greater velocity. We can put these two terms together to make the equation for kinetic energy. The amount of kinetic energy stored in an object can be found by multiplying half by the mass by the velocity squared. Kinetic energy, being energy, is measured in joules. Mass is measured in kilograms, and velocity is measured in meters per second. It's really important when you complete any calculation using this formula that your units are correct, otherwise your final answer won't be. We have a 65 kilogram boy running at 7.2 meters per second. Both of those quantities are given to 2 significant figures, and we've been asked to give our answer to 2 significant figures as well. I know that the 65 represents the mass because kilograms are the units for mass, and I know that the 7.2 is a velocity because meters per second are the units for velocity. So I'm going to do half, or 0.5, multiplied by 65 multiplied by 7.2 squared. That turns into half times 65 times 51.84, and that gives me an answer of 1684.8 joules, because of course kinetic energy is a type of energy, so it's measured in joules. But that answer isn't 2 significant figures, and so it won't get me the full amount of marks. So now I need to round it, and I get 1700 joules. That's my final answer. Here are 4 similar questions for you to pause the video and have a go at. Remember, we're only squaring the velocity term, so I would personally do that before you add it into the calculation, and also don't forget to watch out for any sneaky units. So in question 1, the mass is 920 and the velocity is 21. So 21 squared is 441, giving me an answer of 202,860. But that's not 2 significant figures, so I need to round it. 210,000 joules. Then for question 2, I go through the same process and I get 2,684,687,500 joules. So if I round that to 2 sig figs, I get 2.7 billion joules. For question 3, I need to watch out for the fact that the mass of the basketball is not given in kilograms, so I'll need to convert it. That gives me an answer of 5.5125 joules, which rounds to 5.5 joules. And then finally, for question 4, 34,300 joules rounds to 34,000 joules, and that's my answer to 2 significant figures. By now, if you've been watching the rest of the energy series, you're used to this idea that we need to be able to rearrange all of these equations. So let's look at how we'd calculate mass using this equation. We want to get rid of the half, so we're going to double everything. 2 times kinetic energy is mv squared. Now we want to get rid of the v squared. Right now it's multiplying the mass, so to get rid of it we do the opposite of multiplying, which is divide. Whatever we do to the right side, we do to the left, so we divide that by v squared as well. So if I want to calculate the mass of a car that has 48,600 joules of kinetic energy while travelling at 9 meters per second, I'm going to do 2 times 48,600 divided by 9 squared, or divided by 81, and that gives me an answer of 1200 kilograms. Here are 4 more questions of this type for you to have a go at, so pause the video now and write down some answers. For question 1, we get an answer of 840 kilograms. For question 2, 84.9704, so we're going to round that to make 85 kilograms. For question 3, 509.89 kilograms, which rounds to 510. And for question 4, 0.05625 kilograms, which rounds to 0.056. Finally, we're going to use the same equation to calculate velocity. So, firstly we need to get rid of the half, and we do this by doubling everything. 2 times the kinetic energy is mass velocity squared. Now we want to get rid of the mass. Right now it's multiplying, so we need to divide. And now we want to get rid of this squared sign to get v on its own. So we're going to square root everything. So now I can calculate the velocity of an object that has a mass of 5.2 kilograms when it has 842.4 joules of kinetic energy. So I start off by doubling the amount of energy, and then I need to divide it by 5.2, and then I take my entire answer and square root it. So I'm going to work out the square root of 324, which is 18 metres per second. These final 4 questions are all in the same format as the previous worked example, and you have got the rearranged equation there in the top right hand corner. So pause the video now and write down some answers for these last 4 questions. So for question 1, we start with 847 joules of kinetic energy. We double that, then divide it by the mass of 14, and then square root the entire answer. That gives me a velocity of 11 metres a second. Then for question 2, we're doing 2 lots of 4,600 joules of energy divided by the mass of 92 to give an answer of 10 metres per second. Then for question 3, we double 13,448 and then divide that by 16. And that gives an answer of 41 metres per second. And then finally, 2 lots of 7,415 divided by 52 gives a velocity of 17 metres per second. Thank you for watching, and I hope this was useful. If you've now watched this video and the GPE video, I'd recommend you checking out the video looking at extended calculations that need both of these formulae to answer one question. Then we move on to efficiency. If you found this useful, don't forget to like and subscribe for more GCSE Physics videos coming soon.